We're going to look at inequalities in one triangle. Okay, when we do section 5-6, that's on inequalities comparing two triangles. Right? So today we're just going to look at one triangle. All right, let's start off with a couple theorems. Okay, theorem 5.10. Okay, it's page 295. So if you don't want to copy the whole thing now, that's where it is. Okay, it's a pretty straightforward idea. It says that if one side of a triangle is longer than another side, then the angle that's across from the longer side is larger than the angle across from the shorter side. All right, so you've got two sides in a triangle, and one side is longer than the other. The angle opposite the longer side is bigger than the angle across from the shorter side. Okay, so here's a kind of an example. Let's see if we can apply that theorem. Side AB is 3 units long. Side BC is 5 units long. Which angle would be larger in that picture? A or C? A. Why would A be larger? It's across from the bigger side. Angle A is across from the bigger side. Angle C is across from the smaller side. That means angle A is going to be bigger than angle C. That's always true. Any type of triangle. Okay, there will be a question on the midterm very similar to this. It's actually going to involve two triangles. Okay, but this idea will be very important for that question. Okay, any question on theorem 5.10? 5.10. Okay, let's look at theorem 5.11. Same page, 295. This theorem kind of switches around what you know. Instead of knowing the lengths of the sides, this time you're going to know how big the angles are. Okay, but it's very similar. Okay, it says if one angle in a triangle is larger than another angle, then the side across from the bigger angle is the longer side. And the side across from the smaller angle would be the shorter side. Okay, so theorem 5.11, again, if one angle in a triangle is bigger than another, then the side across from that angle is bigger than the side across from the shorter angle, or smaller angle. Usually we say shorter when we're talking about the length of something. We say larger or smaller when we talk about angles. Okay, so let's take a look at that. Okay, so my question here is I want to compare sides FE and FD. If you were going to write down FD, you have a blank, and then FE. What would go in the blank? You have a choice of a less than, a greater than, or equal to. It could be equal, but in this case, they're not equal. Yeah. Go ahead.
FD is less than FE?
Yeah. FD is across from a 40-degree angle. FE is across from a 60-degree angle. FE is across from a bigger angle. It's going to be a bigger side. FD is going to be the smaller side. That looks like less than or equal to. So let's do it like that. Is it okay to write it the way I did on the other side? Is that the same thing? Yeah, I switched the orders of the letters. I said EF, which is FE, is greater than DF, which is FD. These mean the same thing. They're just written differently. But it's good to be able to recognize the same statement written different ways. Any question on that? So basically, the kind of the short summary of both of those theorems is that the biggest angle is always across from the biggest side, and the smallest angle is always across from the smallest side. And then the angle that's in the middle is across from the side that's in the middle. We use that fact a lot in trig. Biggest angle across from biggest side, smallest angle across from smallest side. Now that might help make an isosceles triangle make a little bit more sense. Okay, we've always said that in an isosceles triangle you have two angles that are the same and two sides that are the same. Well, now we could use our theorems we have up above to kind of show why. Right? So you got two sides that are the same, then the angles across from those sides also have to be the same. If one side was larger than another, then one angle would be larger than another. But they're not. They're the same size sides, same size angles. Hey, any question on that? All right. So let's look at this, and I want to write down in order the smallest side first, up to the biggest side. Okay, who can tell me what the smallest side is, and don't always go by how the diagram looks. It might not be drawn to scale. Okay, pictures might not be drawn to scale. Go by the angle measurements. Yep, smallest side again?
HJ.
Yep, HJ. All right, so we get side HJ is the smallest. You know what, let's write it as a segment. Segment HJ. Okay. What's the next largest side?
JG.
Yep, JG. And finally, who can tell me the largest side? Yeah, HG. Okay, so here's the sides. Let's do the same thing for angles. Denver, what's the biggest angle there? Yeah, what's its name? Angle J. Okay, actually, if we're going to do them in the same order, let's put that one at the end. All right. Angle J. What's my smallest angle there? James? Angle G. And the only angle we haven't used yet is angle H. Okay, so notice the pairing. Angle G is across from side HJ. Smallest side, smallest angle. Biggest angle is angle J. Biggest side is HG. Biggest angle across from biggest side. What's left? The angle that was in the middle and the side that was in the middle. Okay, let's try this one. This time, instead of giving you your angles to start with, you're using your sides. So this is the other theorem. Okay, but it's the same idea. Let's start with our sides. Okay, Nick, what's my longest side there? All right, you know what? We'll start with shortest. What's my shortest? QP. Yep. Okay, Morgan, next longest side. RP? Yeah, I'm just going to name it PR since he said QP. I'm just going to keep my letters kind of going in the same direction. But yep, that's fine, PR. And my longest side, Olivia? RQ. Good. Okay, now we'll do our angles. Denver, what's my smallest angle? Nope, not angle Q. Angle Q is going to be in the middle. Angle R. Why?
Because it's opposite from the shorter side.
Yes. Remember, smallest angle across from smallest side. All right, so now my next biggest angle would be angle, yep, Selena? Angle Q. And now RQ, that's the biggest side, so the biggest angle, angle P. Any questions on that? If I ask you to on a test just to list in order, biggest sides, biggest angle, either largest to smallest, smallest to largest. All right. This was a theorem we had earlier on. What was the name of that theorem? I think I said it before we started class too. The measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Yeah?
Alternate interior theorem.
So alternate interior angles, you're thinking when you have lines and then cut by a transversal.
Alright, so that's
These would be like alternate interior, if these were parallel. But they would be equal. Anyone else? Remember if you're not sure what it's called, think of what angle 1 is called, what kind of angle that is. And then that'll tell you the name of the theorem. Yeah?
What's the angle addition theorem?
Nope, not angle addition, but that is a good one to know. That's important. Angle addition is when you take something like this, and you say that angle ABC plus CBD equals ABD. That's the angle addition postulate. Okay, but that's good. It's good to remember that. Anybody else? Remember, think about where angle 1 is in that triangle. There's two places an angle can be. It can be, yeah?
Does it have something to do with like exterior?
Yeah, this is the exterior angle theorem. Okay? And we proved it. At least I think we did. So we're not going to go back and prove that again. But the proof of that is very, very straightforward proof. Okay. Now, what do we know about angles 2 and 3? Or what do you know about any angle in a triangle? Anybody give me kind of a restriction on what the angle would have to be? Yep.
all the angles have to add up to 180.
Okay, they all have to add up to 180, so that's important. What else? Let's say you just focus on an individual angle. If I said I got an angle in a triangle, what can you guarantee me that angle is between? Could it be 225 degrees? No.
It has to be between 180.
Well, between means we got to have two numbers. Between, so you said 180, that's good. And how small could an angle in a triangle be? It's got to be bigger than what?
Bigger than 0.
Yeah, it just can't be 0. But an angle in a triangle can be anywhere between 0 and 180, not including 0 and 180. Right? Think of a triangle like this. Okay, that angle starts to get larger and larger, gets very, very close to 180, and these two angles here and here get very small. Right? So we know that angle 2 and angle 3 have to at least be positive. Okay? They've got to be bigger than 0. Yeah?
You can't have an angle that's 179 degrees,
You could. You could have like 179, 0.5, and 0.5. Yep, it's going to get very, very...
can you? I was thinking like you couldn't have like a 0 as an angle.
Yeah, you can't have 0. But you can have a 1/2, a 1/2, and a 179. That's okay. All right, so we know that angles 2 and 3 at least have to be 0. All right, so that idea leads us to another theorem. See if we can figure it out before I show you. What do you think if you compare angle 1 to either angle 2 or 3, how would it compare to them? keeping in mind angle 1 is the sum of angles 2 and 3. So if I said, here's angle 1, here's angle 2, and you compared them, how would they compare? Angle 1 is larger. Angle 1 is always larger. How about if you compared angle 1 and angle 3? It's always larger. It has to be. Right? If you're finding something that's the sum of two things that are not 0, okay? Neither one of those can ever be 0. Angle 1 is always going to be larger than either one of those individually. Always. So that's our theorem. Okay, and that's the exterior angle inequality. Right, so that says that the measure of an exterior angle is always greater than the measure of either of the two remote interior angles, or we could say non-adjacent. So the exterior angle in a triangle is always larger than the two remote interior angles. Always. It has to be. Okay, and that theorem, that's on page 296. Any question on that theorem? Yeah. Okay, so that's the exterior angle theorem. Right, we're not going to do a whole lot with that theorem, but it's just a fact I'd like you to understand. The exterior angle is always bigger than the two remote interior, or non-adjacent, if you want to say it that way. All right. So something we are going to do a little bit more, and I explained at the beginning, if you take any three segments, can they always form a triangle? Okay, let's take these three and see if we can make them into a triangle. Before we start, what do you think? Think we can take those segments and make a triangle? Who thinks we can? We can turn them, we can rotate them, however we want. Okay, a few people think we can. Anybody think you can? No matter how you turn them, rotate them, try to connect them, they'll never connect. Anybody think we can? Okay, well that's cool. 4 people think we can, and there's more than 4 people in here, and people think we can't. So no, it's got to be a nice, neat triangle, all connected. So we got a lot of undecided votes, maybe. Yeah.
I think we can make a triangle.
Think you can? All right, let's try. Well, it's good. At least you have an opinion.
Can I try?
You want to try? Yep, you can try. Yep, you click on it. You can rotate it. So the only problem that I see is that long side. Okay?
Okay.
So you can drag that.
Okay.
Yep. Your job's harder than you think.
Yeah.
You can turn it. Yep. So we got that.
That's good. So like just make it a little bigger.
But yeah, we can't change the size of it. Yeah.
Okay.
Trying to move it up.
Yep.
There you go.
Okay.
Is that going to reach both of them?
Anything's possible.
Let's see.
Okay. We'll have to do it.
It's not gonna work.
Yeah, I don't think it's going to get to work. So even if you,
I know I can do it.
well, it's got to reach from here to here.
Oh, okay.
Right. Yeah, that's not going to work, is it? Yeah. So the best you could kind of do is try to make it, reach, and it's not. It's not going to reach. Okay.
At least I tried.
So you tried. That was good. You tried.
That'd be good for the house. You could actually get inside.
So the point here is not every group of 3 segments can make a triangle. Okay? There has to be a certain relationship between the sides. All right, and the relationship is going to involve an inequality, since we're studying inequalities. And what we're going to do is we're not going to have visual segments that we try to fit. I'm going to give you numbers. Like maybe in this case, this is a side of 5, 4, and 1. I could tell if you just gave me numbers 5, 4, and 1, it would never work. I could figure out that it's not going to work without trying to sketch it. Okay, so we're going to try to figure out what's the special relationship. Anybody know what the relationship is? How, if you get 3 random numbers, you can figure out if they would make a triangle.
That would work. If they add
If they add up?
no.
Well, it has something to do with addition. It does have a little bit to do with addition. Yeah?
Doesn't the sum have to be divisible by 3, like both sides?
Does the sum have to be divisible by 3? No. No, it doesn't have to be divisible by 3.
You could have 1, 2.
But that's a guess. Any other guess before we look at how you figure it out?
That won't add up. Well, that won't make a triangle because 3 is too small. It's not. It wouldn't fit.
The 3 is too small? What if I make it 4? Would that be long enough?
No.
No? Actually, it would be. If you just made this won't work. That will. Okay. Let's see how I figured that out.
But you have to have 2 odd numbers. No, 1 odd number, 2 even numbers.
Well, another good guess, odd or even. We could have decimals, though, too, which are neither odd or even. So,
There could be a huge gap in the number that you can put odd and even.
so yeah, it doesn't necessarily have to do with odd or even. In fact, you can have all even sides. Think of an equilateral.
Does it have to do with the difference between?
You could look at it as a difference, but we're going to look at it more as a sum. You're on the right track with addition. So the idea is that the sum of the lengths of any 2 sides have to be bigger than the third. They can't equal, it has to be bigger. So what you do is you look at all your sides, you add up each pair and check. Is that pair bigger than the other side? And do another pair. Is that pair bigger than the other side? And then check the last pair. So there's 3 pairs you need to check. Okay, so the relationships that would have to work to make this a triangle. If I add AB to BC, it's got to be bigger than the third side, AC. If I add BC to AC, it's got to be bigger than the third side, AB. And lastly, if I add the side on the right, AB, to the long side there, AC, that has to be bigger than the bottom, BC. So if you add up any 2 sides, it's got to be bigger than the third. So now if I gave you 2 numbers, and I could say, what would be some possible lengths for the third side? There's a minimum length it could be, and there's also a maximum. And anything in between that minimum and maximum would work. Okay? So we'll try one like that. Anybody know the biggest that the third side could be in this triangle? If you had a side of 3 and 8, or actually a better way to say it is it would have to be smaller than this number. Oop.
It has to be smaller than
10 and a half would actually work here.
It has to be smaller than 11.
Has to be smaller than 11. Yeah.
Bigger than
3 plus 8 is 11.
Yeah, would 10.9 count?
Yep.
So
Smaller, anything less than 11.
I can just do 10.9999999999999.
Yes.
that would.
It'll be almost exactly, what does it matter? If it's
10.9.
exactly-
As long as it's less than
If it's
11.
then it's not a triangle anymore?
Yep.
Doesn't make any sense.
Yep.
It has to be.
Just think a bit about a gap getting smaller and smaller and smaller and smaller and smaller until finally it's not a gap. Yeah.
All right. What's 1,000 years called?
1,000 years, like a millennium?
It's a millennium.
Yeah. Is there any connection with that or no? Just a question.
I was just.
Just couldn't remember. All right, so let's look at this one. A triangle, it's got side lengths of 10, 14. I want you to tell me the possible lengths for the third side. Okay? Let's let x be the length of the third side. And maybe a sketch. If you're not sure, just make a sketch. 10, 14. I want to know the lengths for x. Okay, again, that sketch is not to scale. Just a quick sketch. Can anybody give me, you know what? Let's do all three. Let's write down all three of these inequalities using that triangle. Who can give me one of them? Yep.
10 plus 14 is,
Mhm.
I don't know, is it greater than x or is it
Yeah,
less?
greater than x. Any two sides have to add up to be bigger than the third. Okay, so that's one. We'll solve that in a minute. Okay, can somebody give me a second one? Yep.
X plus 14 is greater than 10.
X plus 14 has to be greater than 10. Leave a little space. We'll solve that one. And how about the third one? Ian?
X plus 10 is larger than 14.
X plus 10 is larger than 14. Good. Okay, now let's solve each one. Okay, first one's easy. 10 plus 14, 28.
24.
Oh yeah, thank you. 24 is greater than x, which basically means, what's another way to say that? 24 is bigger than x, but we could say
X is small.
x is smaller than 24. Let's say it that way. Okay, so that fact has to be true. Okay, how do you solve this one?
Connor, you know how to solve this?
But I'm not going to.
How do we solve that? Kira?
Subtract 14.
Subtract 14. Good. So we get x is larger than what? Negative 4. Is that helpful? Why doesn't that really tell us anything? Can't have a negative length anyway. I could have told you that x is always bigger than negative 4. So when you set up these inequalities, there's usually one of them that doesn't tell you anything. This is the one that doesn't really help you. Let's solve the last one. What do I do on each side to get x by itself here? Yep. Subtract 10. So we get x is larger than 4. These are the two facts that are going to help you figure this out. Okay, so I like to write the inequality as a compound with x in the middle. I use less thans. And write it like this. There's your final answer. X has to be bigger than 4. Okay, we got that from the last inequality. But it also has to be less than 24. So this is a conjunction. What word do you use with a conjunction in math?
Is.
No, not is. There's a conjunction and a disjunction. Same thing in English. What word in the English language is a conjunction? And. Good. X is greater than 4 and x is less than 24. This is not an or. You can't say, well, x could be bigger than 4 or. No, it's an and. Both of these have to be true. Right? So you could pick any number between 4 and 24. Could you use exactly 4 or exactly 24? No. There's no equal to's here. Right? If there was an equal to, then you could.
So you use 5.00001.
Yep, 5 is bigger than 4 and less than 24.
Use 5.
Yep. Okay, this one, this time I'm not going to have you try to figure out the third length. I've already figured it out, and I want to know, is it possible to make a triangle? Sides of 3, 3, and 8. So it'll be a yes or no, and then if it's no, I want you to tell me, show me what doesn't work. Oh, Dakota? What do you think? So what's your rule? What's the process you're going through to figure out whether those sides make a triangle or not?
I'm trying to think of something like the same length.
Well, we have a theorem, right, from the last page? What's that theorem we have to use? Okay, that's true. Shortest leg goes with shortest angle, shortest things like that. But that's not going to help us here. Okay, so our theorem, we used it on these problems. Anybody explain what did we do in these 3 steps? How did we set up those inequalities? We know that. Tell me the theorem.
We need to know each segment and do a segment added by another segment is greater than the opposite segment.
Yeah. Any 2 sides of a triangle have to add up to be larger than the third. Okay, and you've got to check that 3 times. All right, so let's go back. We have sides 3, 3, and 8. Okay. So what do you think, Dakota? Based on that theorem, could those 3 sides make a triangle? So we're checking that any 2 sides added together are bigger than the third. Okay? Let's run through all of them. Can you give me one pair of sides added together? Just add up any 2 you want.
3 and 3 or 6.
3 plus 3. Okay, and the question is that bigger than which side?
8.
8. Okay, is that true? No. So what does that mean? No, you don't have a triangle here. The other ones work. Okay, 3 plus 8 is 11. That's bigger than 3. 3 plus 8 is 11. That's bigger than the other 3. But 3 plus 3 is not bigger than 8. So no triangle. How about 6, 6, and 12? Could you make a triangle out of those sides?
No, because 6 and 6, their sum is 12, and it has to be larger.
Right. So the question, is 6 plus 6 larger than 12? No. Doesn't work. Okay. The reason what kind of shape would you have if you tried to draw that? The best you could really do if you had 6, 6, and 12, it would look like what?
No.
So pretend you had a side of 6. Make a copy of it. There's 6. Now put 2 of them together to make 12. Okay, and group them together. What's the best shape you could kind of make there? No, not a cone. We have no curved segments here. It's flat, not 3D. Yeah, you basically could get, if you position,
2D cone home.
you basically could have like parallel lines, right? If you try to put that right on top of it, you just get a segment, okay? You'd need to have it just a little bit longer, okay? If you just made this, let's take one segment, either make one of these segments a little longer or make that a little shorter. Now you can do it, okay? Because what you could do is just take, and to rotate it, I need to group it together. So let's group that.
You need to group it to rotate.
I don't know. I don't know why I can't rotate unless it's grouped with something. That's kind of weird. But then once I group it, I could actually erase the thing it's grouped with. Now I can rotate it. Okay, I just turn it just a little bit. See if, okay, you're going to get a very, very shallow angle and then a very large angle. And same thing here. Just turn it. Actually, I have to be a little longer. But you get the idea, kind of. Right now, it's doable. Okay, but the point is, you got that relationship. It's got to be bigger. 2 sides added up, or it doesn't work. Okay, how about 9, 5, and 11? Could I make a triangle out of those sides?
Yes.
Yeah. How come? Anybody explain to me three things you have to tell me? Yeah?
14 is greater than 11.
So 9 plus 5 is bigger than 11. Okay.
20 is greater than 5.
9 plus 11, that's bigger than 5. Yep.
14 is greater than 9.
And then 14 is greater than 9. So you add up any two sides, it's always bigger than the third. Perfect. All right. Any question on that? Now, if I asked you to actually build that, let's say I gave people a material and asked them to build it, would everybody's triangle look the same? Well, think about that from triangle congruence. If I gave everybody these three sides, right? Everybody would have the same sides in each of their triangles. So they'd all be congruent, but they might not necessarily look exactly the same. Okay? For example, you could have, maybe somebody draws a triangle like that, and then somebody, let's group that together, draws one like this. Okay, that would look the same. But that one's a little different. Okay, it's been reflected. Or rotated, that's different. There's no way you can rotate this triangle to make it look exact if you have a reflection. Okay, because reflections, let's do one like this actually. Take that one. Let's group it, make a copy. Okay. Let's try to rotate the one above it and see if we can make it match up with the one below. Okay, you can try that. That's not going to work. That's not going to match up with it. Is there any way to rotate that to have it line up with the one below? We get it? Well, not quite. It's close, but that bottom side isn't quite long enough, or it's too long. So really, there's no way to rotate the one above it to make it symmetrical to the one below. If there was, we call that rotational symmetry. We'll get into that a little bit. So the answer is everyone's triangle would be congruent. They all have the same sides, but it might be a reflection or a mirror image. Okay, they could be mirror images of each other. Right, try that one on your own. Similar to one we did earlier. You got sides of 8 and 17. Try to find the lengths of the third side. Okay, so what's my first inequality I could set up? Connor?
8 plus 17 is greater than x.
Good. 8 plus 17 is greater than x. Okay, what's another one? Yep.
8 plus x is greater than
Yep, that's good. Let's move it down a little bit.
And hold on.
Try it again. So 8 plus x is greater than 17. And one more. Yeah.
17 plus x is greater than 8.
17 plus x is greater than 8. So if you want to check and see if you got them all, check the right-hand sides. X, 17, 8, yep, you got them all. All right. 8 plus 17 gives me how much?
25.
All right, so I know 25 is greater than x. In other words, x is less than 25. Okay? Let's do the one on the upper right. Subtract 17. Subtract 17. What happens there? Yeah, x is bigger than how much? What does that say? Negative 9.
It's useless.
Yeah, it doesn't, that one doesn't tell us anything. It's the third one. Okay, minus 8, minus 8. Okay, 17 take away 8 is 9. Okay, so two ways you could write your final answer. You could say x is less than 25 and x is greater than 9. That's one way. Anybody write it that way? No? Okay, or you can put x in the middle. Put your less than on each side. Smaller number left, bigger number right. That's a second way. Anybody give me a third way? Kind of like the way above it. Yep.
25 is greater than x,
Mm-hmm.
greater than 9.
Perfect. That's a third way. This says x is less than 25, but x is also greater than 9. So if you do it the combined way, inequalities point in the same direction, and they always point towards the smaller number. Okay. So 3 different ways you can write your answer. All right, so our test tomorrow is going to cover everything from 5.2 to 5.6. Okay, just what we did this week. Okay, and the homework on 298, 7 to 10, all. 12 and 13. 15 to 18, that's all. 20, 23 through 25, all. And 42 and 44.
All.
Yep, all on 42 to 44.